This video is for Thursday, December 6th. We have 26-minute classes today. Feel free to pause this video as needed, and I will also post it on Schoology so you have it for further reference. Today we're going to be looking at momentum and impulse. These are two different ideas that are very connected, and they're connected by Newton's second law, which we know is force is equal to mass times acceleration. Momentum is mass in motion, and it depends on the mass of an object and its velocity, so how fast it's moving. For momentum, we use the letter P, and our formula is momentum is equal to mass times velocity. Mass is measured in kilograms, velocity is meters per second, so our unit for momentum is kilograms meters per second. Mass times velocity. Impulse is very closely related to momentum. Impulse is something that causes a change in momentum, and it depends on the force and the time of contact, or the amount of time that that force is applied. For impulse, we use the letter J, and impulse is equal to force times the change in time. Force is measured in newtons, time is measured in second, so the unit for impulse is newtons seconds. Relating this back to Newton's second law, we know that Newton's second law is force is equal to mass times acceleration. And acceleration is how something's velocity changes over time. So acceleration is really the change in velocity divided by the time. We know that impulse is equal to force times time, so if I were to multiply this by time, I have to do it to the other side of my equation, I would get that force times time, or impulse, is equal to, time cancels out, mass times the change in velocity. Force times time is impulse, mass times velocity is momentum, so impulse is equal to the change in an object's momentum. Remember, the unit for impulse is newtons seconds, and the unit for momentum is kilograms meters per second. So impulse is something that causes a change in momentum. So if we're looking at a golf ball, a force acting on the ball for a certain amount of time can increase its momentum. Momentum is mass times velocity. We know that mass is a property of matter, so mass stays constant. So that means that if momentum changes, velocity has to change. So impulse is something that can change an object's velocity. Jordan Spieth hits a .050 kilogram golf ball, giving it a speed of 80 meters per second. What is the change in momentum of the golf ball? And we know that change in momentum is equal to the mass times the change in velocity. This little triangle is the Greek letter delta. It always means change in. Momentum is equal to, our mass is .050. The ball was starting at rest, so our change in velocity is 80 meters per second. So our momentum is equal to 4 kilograms meters per second, or our change in momentum. The second part of the question asks us, what impulse does he impart to the ball? Impulse is equal to change in momentum. Change in momentum is 4. So our impulse is equal to 4 units for impulse, force, times time. So 4 Newton seconds. Example 2. Wayne hits a stationary .12 kilogram hockey puck with a force that lasts for 1 times 10 to the negative 2 seconds. and makes the puck shoot across the ice with a speed of 20 meters per second, scoring a goal for his team. What force did Wayne impart to the puck? Okay, so we know that our mass is 0.12 kilograms. Our time is 1.0 times 10 to the negative 2 seconds. And our speed, our velocity, is 20 meters per second squared. Meters per second. We want to know what force did he hit the puck with. So we can find the force by using what we know about impulse and momentum. We know that impulse is equal to change in momentum. We definitely had a change in momentum here because we started at rest, and our new speed is 20 meters per second. So we had a change in speed, a change in momentum. Impulse we know is force times time. Momentum is mass times the change in velocity. We want to know the force. So to find force, I would divide by time. And I get that force is equal to mass times change in velocity divided by time. Our mass, 0.12 kilograms. Our change in velocity, 20 meters per second, divided by our time, 1.0 times 10 to the negative 2. Plugging into my calculator, 0.12 times 20 divided by 1 times 10 to the negative 2. I get that my force is 240 newtons. Okay, we will stop here for today, and we will pick up from here on Friday. Enjoy the rest of the day off. See y'all tomorrow.